Hi, in this video we're going to take a look at scalar quantities. So first, before we start talking about scalar quantities, let's discuss what are physical quantities. So we're going to say that a physical quantity is one that can be measured or calculated and expressed in numbers. And because in physics, mostly we concern ourselves with measurements, laws, and calculation, we need physical quantities in order to describe what we're talking about. And we have to be able to talk about those physical quantities using their magnitude, or more commonly used, the size of those quantities, and also sometimes the direction of those quantities. And here I'm going to highlight that there is a distinction between quantities that have magnitude only and quantities that both have magnitude and direction, both. So the first type, the quantities that have magnitude only, are called scalar quantities. So we're going to define a scalar quantity as one with magnitude only. It has no directional component. And there is quite a few of those quantities on the physics syllabus. Some of them include length, mass, time, temperature, pressure, volume, or speed. And we're going to look at some examples of some of those. So first we're going to define length. And if you look at the diagram over here, I can see that I marked 2 points, point A and point B, and I marked a line, straight line between those 2 points, and I call that line S. So the size, the length of that line is what we're looking at over here. It's length or distance. So the distance between 2 points is a measure of how far one point is from the other. And occasionally, instead of saying the words distance, we use the word length, and in physics, those two usually have the same meaning. And both are scalar quantities with an SI unit of a meter. And just to be clear, a scalar quantity is a quantity that has size only. It has only magnitude, doesn't have a directional component. Another important quantity that is a scalar is time. So time is used to measure the duration of events so that we can put them in sequence or figure out how delayed are they between one another. We can also think about what event is shorter or longer, and time is the quantity that allows us to do those comparisons. Time is a scalar quantity with an SI unit of 1 second, not 1 minute, not 1 hour. The unit of time is 1 second. And finally, we can say that we measure time using a stopwatch or an electronic timer. So when we combine length and time, we end up with a quantity called speed. So we're going to define speed, usually denoted with letter V, as distance traveled per unit time, so distance per second. And if we look at how we calculate the value of speed, we can say that speed, usually denoted with letter V, equals to distance over time, or in other words, V equals to S over T, where V is speed, S is distance, and T is time. And because speed is a scalar quantity, it has no direction, and we can say that its unit is meter per second. And that's it for today's video. Thank you.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.